Entering the world of industrial automation. Hello everyone, today I will continue to guide you in exploring the world of industrial automation, with a focus on PLC control technology, in particular the design and simulation of a conveyor sequential start or stop control system based on the S7-1200 PLC. Let us work together to unlock the principles of PLC control technology and understand the critical role of the scan cycle in control system design. We will also explore intelligent control technologies. In today's industrial production, the application of automation technology is ubiquitous. Intelligent control technology, as an important branch of automation, has further driven industrial production toward higher efficiency, precision, and intelligence. Through intelligent control technology, we can achieve precise control and optimization of complex production processes, thereby improving production efficiency, reducing production costs, and ensuring the stability of product quality. Unlocking PLC control technology. PLC, short for Programmable Logic Controller, is one of the core devices in modern industrial automation. It features high reliability, strong anti-interference capability, and simple programming, and is widely used in various industrial control applications. Today, we will focus on the design and simulation of a conveyor sequential start or stop control system based on the 1200 PLC, to gain deeper insight into the essence of PLC control technology. Module 2: Basic Instructions and Applications of the S7-1200 PLC. In this module, we will study the basic instructions and applications of the S7-1200 PLC and, through a specific task, the design and simulation of a conveyor sequential start or stop control system. Learn how to apply these instructions in practical control scenarios. This task involves important concepts such as sequential control and scan cycle analysis. Through a detailed analysis and design process, we will help you gain a deeper understanding of the important roles these concepts play in PLC control. First, in the task description, our objective is to design a PLC-based multi-section conveyor sequential control system. This system must meet the following requirements. 5 conveyors start sequentially in the order M1, M2, M3, M4, M5 with a 5-second interval. They stop in reverse order, that is, M5, M4, M3, M2, M1. In the event of an emergency stop, all outputs are cut off immediately. Timing conflicts are resolved through scan cycle analysis. The specific control requirements are as follows: there is one start button, one stop button, and one emergency stop button. Each time the start button is pressed, one motor is started sequentially. Each time the stop button is pressed, the most recently started motor is stopped. When the emergency stop button is pressed, all motors are stopped. The system allows starting or stopping at any time. Second, let us look at the task objectives. Through this task, we aim to achieve the following goals. In terms of knowledge objectives, we will master the 3 stages of the PLC scan cycle: input sampling, program execution, and output refresh. We will also understand the state transition conditions of sequential control and become familiar with setting safe time intervals for starting and stopping multiple devices. In terms of skill objectives, students will be able to design trapezoid diagram control programs. They will be able to optimize the program structure by monitoring the PLC scan cycle. They will be able to handle continuous race conditions caused by the scan cycle. They will also develop the ability to design emergency stop circuits. In terms of professional quality objectives, first, balancing real-time performance, reliability, and cost in system design, for example, selecting an appropriate PLC model. Second, understanding the differences between theoretical calculations such as scan cycle budgeting and practical commissioning. PLC scan cycle. The working principle of a PLC is based on a cyclic scanning operation. A complete scan cycle consists of 5 stages: self-diagnostics, communication processing, input scanning, program execution, and output refreshing. The duration of the scan cycle mainly depends on the length of the program. Generally, the PLC can perform dozens of scans per second or more. For systems with strict timing requirements, accurately calculating the response time, carefully structuring the program, and reasonably arranging the instruction order are crucial. This helps to reduce the adverse effects, such as response delays, caused by the scan cycle. The cyclic scan time of the S7-1200 CPU, also known as watchdog time, is set to 150 milliseconds by default. It can be modified up to a maximum of 6,000 milliseconds. After programming is complete, it is necessary to check the cycle time of the program. This can be done using the following method. After downloading the program to the PLC, establish an online connection. Check the path, online and diagnostics cycle time. Why can't the PLC run after the program is downloaded? The PLC diagnostic information shows exceeded maximum program cycle time. Possible reasons. First, the program is too long and the execution time exceeds the set maximum cycle time. Second, a dead loop in the program causes the execution time to exceed the maximum cycle time. Third, timed interrupts. The execution time of the program exceeds the set time interval for the interrupt, causing the interrupt event buffer to overflow, leading to a shutdown. Let's go over the workflow. We have 5 motors, and when you press the start button, motors 1 through 5 will start sequentially. Each time the stop button is pressed, the most recently started motor is stopped. When the emergency stop button is pressed, all motors are stopped. Remember, you can choose to start or stop the motors at any time during the process. Now, when working with I/O devices in a PLC control project, the first step is to clearly define the controlled object and determine the necessary I/O devices. For this project, we need to define the input signals such as the start button, stop button, and emergency stop button, and the output signals such as the control signals for each motor. For PLC programming, we will use the TIA Portal software. Based on the control requirements and the design program flow, we can complete the conveyor belt sequential start or stop control system programming. Here are the main steps. Create a new project. Open the TIA Portal software. Create a new project. Name it Project 1 or any other name. Enter the project view. After creating the project, click on Project View to open the programming interface. Proceed to hardware configuration. Add the PLC hardware. Set the PLC and the local computer's IP address. Ensure that both are on the same subnet. Enable the PLC clock function. Configure the PLC properties and enable the clock function. Set the MB0 byte as the clock memory. Define PLC variables. Name the input and output signals. Create the PLC variables table. This helps with programming and debugging. Write the PLC program based on the program design approach. Write the sequential start or stop control system. Ensure the logic is correct. Then, reset the counter and output to the motor. Once the program is complete, we can proceed with simulation debugging. To do this, we will use simulation software to test and refine the program. The simulation tool in TIA Portal software is S7 PLC Sim. It allows us to simulate the operation of the PLC program on the computer. This effectively helps verify the correctness of the program design. The steps for simulation debugging are as follows. Right-click on the project name at the top level of the project and select Properties. In the pop-up window, select Protection. Check the block compilation supports simulation checkbox. Click OK. Click the Compile button in the toolbar to compile the program. Click the Simulation button to start the simulation environment. Through simulation, we can simulate the conveyor belt's sequential start or stop. Check if the program can correctly implement sequential start, reverse order stop, and the emergency stop function. At the same time, you can also monitor the scan cycle to optimize the program structure. Solve the issue of continuous competition. Now, let's summarize the key points we've covered in this task. The scan cycle is a core consideration in PLC program design. Sequential control must take into account the mechanical characteristics of the equipment. The safety circuit should be independent of program control. During simulation, scan cycle fluctuation should be simulated. This ensures the system's reliability and safety. Through scan cycle analysis, we successfully implemented the conveyor belt sequential start or stop control system design and simulation. This has provided valuable experience for practical applications in the industrial automation field.